All right, this is on simplifying radical expressions. We're going to go ahead and complete this table. So the first row is our 1. So we're going to square 1. So 1 times 1 is 1. 1 times 1 times 1 is 1. 1 times 1 times 1 is 1. And then we go to 2. 2 squared is 4. 2 cubed is 8. 2 to the 4th power is 16. Then we go to 3. 3 times 3 is 9. 3 times 3 times 3 is 27. 3 to the 4th power is 81. 4. 4 times 4 is 16. 4 cubed is 64. 4 to the 4th power is 256. 5 squared is 25. 5 cubed is 125. 5 to the 4th is 625. 6 squared is 36. 6 cubed is 216. 6 to the 4th power is 1,296. 7 squared is 49. 7 cubed is 343. 7 to the 4th power is 2,401. 8 squared is 64. 8 cubed is 432. 8 to the 4th power is 3,456. 9 squared is 81. 9 cubed is 729. 9 to the 4th power is 6,561. 10 times 10 is 100. 10 cubed is 1,000. 10 to the 4th power is 10,000. I'm not going to complete the squares, cubes, and 4th powers. Okay. You're probably familiar with finding the square root and square root of a number. These operations are inverses of each other. Similarly, they are roots that correspond to larger powers. So 5 and negative 5 are a square root of 25 because 5 times 5 is 25 and negative 5 times negative 5 is 25. 2 is the cube root of 8 because 2 cubed is 8. 2 and negative 2 are 4th roots of 16 because, again, 2 to the 4th power is 16. Negative 2 all to the 4th power is also 16. So we say then A is the nth root of B. The nth root of a real number can be written in radical form, where n is the index and A is the radicand. So A is the radicand and n is the index. When a number has more than one real root, the radical sign indicates the principal or positive root. So here are the number and types of roots. When you have an odd index, you will have one root. So for example, the third root of 8, so the third root of 8 is 2. The reason why is 2 cubed, and then the answer will just be 2 because the root and the power will cancel out. Next one, if you have an even index, you will have a positive radicand, so a number that's positive underneath the radical sign. Then you'll have 2 roots. So there's an example here. The 4th root of 16 can be 2 or negative 2 because you have 2 to the 4th power, which is 2, or negative 2 to the 4th power is negative 2. The next one, even index, but you have a negative radicand. You'll have 0 real roots. The reason why is if I take the 4th root of negative 16, you will not be able to get negative 2 to the 4th to be a positive only number. So this does not work. So we call that a non-real solution. then the last one, the radicand is 0. So I take the cube root of 0 and we get 0. So we'll get 1 real root. All right, example 1. Simplify the following square roots. So we have a square root, so the square root of 16. So the index is 2, it's not showing there. So I'm going to just rewrite 16 as 4 squared. So we're going to get 4, and then that could be a plus or a minus because it has an even index. So even, we go up to our chart here. We have an even index and a positive radicand. We can have 2 real roots. The next one has a even index, but there's a negative radicand. So this one will be 0 real roots. Next one. Now we're going to go to odd indexes. So now we have an odd index. I'm just going to rewrite that 8 as 2 cubed. And so you're going to get 1 real solution because the index is odd. Next one, we're going to rewrite negative 216 as negative 6 times negative 6 times negative 6, or negative 6 all cubed. So then your answer will be negative 6. 1 real solution again because it's odd. Last one of these, I'm going to rewrite 125 as 5 cubed. So our answer will be 5. Now we're going to go to 4th root. So now we're back to an even index. So I'm going to rewrite 256 as 4 to the 4th power. And it could also be written as negative 4 to the 4th power. So both of those work. So you could have plus or minus 4 because again our index is even. The 4th root of negative 124, notice that this is a negative radicand. So we have 0 real roots. We call this then imaginary. We worked with i's before. All right, now we're going to go to 6th root. So we're back to an even index. So 6 root, and I'm going to rewrite that 64 as 2 to the 6th power. So our answer will be plus or minus 2. 6th root of 1 to the 6th power. Again, even index will be plus or minus 1. Here are 2 properties. We have the product property. Here's an example. And we can separate out the 2 radicals or combine them back together. The second one is our quotient property. Here's an example. We can combine them together or separate them out. Simplify the following radicals. So we have the cube root of 27, x to the 6th. So our index is 3, so I'm going to separate out 27 into its own radical, and then x to the 6th power as its second radical. And now we're looking for the cube root of 27, so I'm just going to rewrite that as 3 cubed. That should be a little 3 here. My index is not showing up here. So I'll move it over a little bit. And I'm going to rewrite x to the 6th as x to the 3rd power squared. I'm going to go one more time. So 3 cube root of 3 cubed, cube root of x cubed, and then cube root of x cubed. So what will happen is the index and the power cancel out, so we're just left with a 3. Cube root of x cubed is just an x. Cube root of x cubed is just an x. So we combine those back together, giving us 3x squared. All right, now we have a 4th root. So I'm going to separate that out into the 4th root of 81. And I'm going to go x to the 4th power, 4th root, x to the 4th power, 4th root, x to the 4th power, 4th root. Now since we have an even index, that 4th root will produce 2 solutions. So I'm just rewrite 81 as 3 to the 4th power. And then we're going to get a plus or minus 3. Then we're going to get an x, and an x. So let's simplify down 2. So that becomes 3x cubed plus or minus. Our last one, another 4th root. So I'm going to break that down into the 4th root of 16 and the 4th root of x to the 4th. Now 16 can be rewritten as 2 to the 4th. And we have another even index, so we're going to have a plus or minus 2, and then x. We're going to use our quotient property. I'm going to separate into 2 radicals. And now notice what happens up in the numerator. In the numerator, the cube root of x cubed is x, and in the denominator, we just leave that alone. All right, quotient property, separate out into 2 radicals. And then I'm going to separate out that numerator into 2 radicals using my product property, so x to the 4th and another x to the 4th. And then in the numerator, that simplifies to an x times an x over 4th root of 3, or x squared over 4th root of 3. And we should probably put a plus or minus here because that's an even index. All right, back to an odd index. So we have the cube root of 64, and then cube root of x cubed, denominator, cube root of 8, and then the cube root of 64, I'm going to rewrite that as 4 cubed, cube root. Cube root of x cubed is x. 2 cubed, and then denominator for 8. So the cube root of 4 cubed is 4. X divided by cube root of 2 cubed is 2. And then you can reduce that fraction by a common factor. So you're left with 2x. Back to the product property. Now I'm going to go ahead and combine these 2 radicals together. They have the same index. They're both an index of 3. So we have 1 radical. And I'm going to combine those x's together. Notice there are a total of 9 x's. And I'm going to separate back out into x cubed, another x cubed, and one more x cubed. So this will become x times x times x, or x to the 3rd power. Next one, we have another index of 3. So we can combine them as x to the 9th. And now notice we have the same answer that we had here. So that will reduce down to x cubed.